Hello and welcome back to Calculus 2, its review. For exam 2. So, yeah, due to the crash, I lost the list from last time, but you know that the exam is on chapter, whatever, 7. And I know that I emphasized that you should be careful of U sub. Always test and check for U sub first, even though it's Calc 1. It's the most basic integration technique. Make sure that you are using appropriate rules. Some problems will say use blah blah, some problems will say just integrate, and then you figure out what. If you see a definite integral, make sure it's not improper, because if it is improper, you have to put that limit. Limit per step is 1 point, right? Or -1 if it's not there. So technically your exam might work out to be -13 if you forget all of the plus c's and limits and dx's along the way. It triggers my allergic reaction to, and then I spaz -1 every time. It's just, I can't control it, that's the problem. I just, you know, called academic Tourette's, I guess. I don't know. The exam will have 10 questions, standard stuff. I don't think there are parts anywhere. I mean, there will be integration by parts. I mean, A, B parts. And, you know, same. Hour 20, hour 25. Keep moving, flip through the whole test, solve the stuff that it's familiar to you quickly, and then keep thinking about other things. Try to focus your strengths, right? Try to focus and solve those problems that you can solve quickly first, so that the rest of the time is right for you to think, oh, is this method, and then you try a method and it doesn't work, and then you switch the method, and so on. So we have trigonometric integrals, we have trig substitution, we have by parts, we have partial fraction decomposition. All of that could use the U sub within. And then any of those could show up within differential equations, which is, right, you integrate to solve differential equation. And any of that can also have limits and become improper as well. So we have to be careful. You are going to take half of the chapter is how to integrate. The other half of the chapter is using that integration, right? So do you have any questions that we could probably do? Yeah. All right, let's go one by one.
Integrate 4 sine cube x cosine square x dx.
All right, so we have an odd power. If we have odd power, that's when you peel off and leave for dx. So this is kick out 4, sine squared x, cosine squared x, and then sine x dx. So we need to transform this into 1 minus cosine squared x, because we are going to use u equals cosine x, and du is negative sine x dx. So for integral, we have, when we multiply these guys, we have cosine squared x minus cosine to the 4th x sine x dx. I need a negative for a sine, so I put the negative there, and I end up with 4 integral of u squared minus u to the 4 du which is negative 4 u cubed over 3 minus u to the 5 over 5 plus c. And we bring back x, right? So negative 4 cosine cubed x over 3 minus cosine to the 5x over 5 plus c. Now you could distribute negative 4, it's not important, but that's here, I'll put on a cloud. That will be the answer for this particular integral. Yes? Integral of dx over? All right, so I'm going to ask a question. What does this integral look like? Okay. So what does this integral look like? Looks like partial fraction if we can factor it, right? If we can factor it, is it partial fraction? No. No. What is it if we can factor it? Completing the square, and that will lead us into... Yep. We love tangent inverse. Okay, he's the expert on it.
I love tangent inverse because it's my tangent.
So, these problems are generally, if you can factor them, they're definitely the partial fraction decomposition. But if you cannot factor, then your best bet is to use the completing the square. So if you complete the square on this one, right, we have x squared minus 2x, and then you go plus 1 minus 1 plus 65. This plus 1 minus 1 is 2 divided by 2 squared, right? That's the B location. We get x minus 1 squared plus 64, which is 8 squared. Wow, right? See that? So it is inverse tangent. Now let's say you don't know it's inverse tangent, because that's also okay not to know that it's inverse tangent from here. What do? Yeah, tricks up, right? You go and you say, all right, I don't know that it's inverse tangent. So you go and you set up the triangle, and then you say these are both legs, so x minus 1 and 8, and this is a square root of x minus 1 squared plus 64, right? And then you have your tangent theta, x minus 1 over 8, from where you get x to be 8 tangent theta plus 1, and dx to be 8 secant squared theta, d theta. And then you have your cosine to get the square root, which would be secant, right? Eventually. But, so what is that? So that will be cosine is 8 over this, so 8 secant there, right? Sorry. Square root of x minus 1 squared plus 64 is equal to 8 secant theta. So now you're substituting everything in. 8 secant squared theta d theta divided by, you have to square it because the problem doesn't have a square root, and this one over here has square root. So squaring both sides will kill the square root, so 64 secant squared theta. And they cancel. So you get 1 over 8 in front, and you get the integral of d theta, which is 1 over 8 theta plus c but theta is the inverse tangent, right? So it's 1 over 8 tangent inverse of x minus 1 over 8 plus c, which you can immediately write if you know the formula for inverse tangent for integration. You can skip all of this work and immediately, as soon as you're done with the completing the square, write the answer if you know how inverse tangent works. So, learning the inverse tangent formula, right, helps you skip some of this work. So, happy with the problem? No, with a smile? All right, yes.
I want to do this one. It's like integrate from 0 to 3, then 3 divided by y squared minus 3y minus 28 and dy.
Professor, I have just one quick question related to that. With the inverse, with sine and cosine, you don't have the 1 over a out front. Is that because those are the only two that don't have asymptotes? So, like, it's like a mathematical explanation.
You can just derive it using the trig sub. You can derive all of those formulas. No one just wrote them down; they're all derived. All right. So wait, this is the same question, like the previous one. Oh, this is partial. Oh, we can. Oh, yeah, 7 and 4. Ah, this is a partial fraction decomposition. Now, limits. What does it mean? I have to check, right? I have to check. So once we factor this, factors over what? Y minus 7 and y plus 4. So the two values where we have asymptotes are negative 4 and 7. See, negative 4 and 7 are not in the interval 0 to 3, so we don't have to worry about improper. You see that? So you have to check that every single time. I told you that once you learn the improper integrals type 2, it's a life-changing event for definite integrals. Going down Calc 3 differential equations and everything else you're going to take in the future. Every time, you saw me do it now, right? I have the limit 0 to 3. Once I factored, I made sure where the vertical asymptotes are. Vertical asymptotes are at 7, which is not between 0 and 3, and negative 4, which is not between 0 and 3. So I don't have to worry about improper integrals in this particular question. But if the interval was 0 to 7, improper integral at the 7, right? Or 0 to 8. Again, 7 is in there, right? So you have to be careful for every question. It could be in the middle. It could be on the one of the limits. And you are allowed to use good old integration if vertical asymptote does not interrupt the interval over which you're integrating.
Well, may I ask you, would that conclude that we would need to use improper intervals?
Yeah.
That means to like identify.
You will have to use it every time when there is a vertical asymptote in that range. So we don't have the issue now, so we can just quickly set this up. A over y minus 7 plus b over y plus 4 is going to give us ay plus 4a plus by minus 7b equals to 3. A plus b is 0. 4a minus 7b is 3 times 7 on top, and we add, so that's going to be 11a equals to 3. A is 3 over 11. right, times 7 on top. That's 7a plus 4a is 11. 7b minus 7b is 0. And then 0 times 7 is 0, plus 3 is 3. So a plus b has to be 0, so b must be negative 3 over 11. No coffee. So now I have integral 0 to 3 of 3 over 11 over y minus 7 minus 3 over 11 over y plus 4 dy. And now, guys, these are linear. That means they're ln's as answers. If they have squares, they're what?
They're angry.
They are arctangents, yes.
They can't be blue points if it's minus.
So I can factor out 3 over 11 in front of the whole thing and have ln of y minus 7 minus ln of y plus 4, exactly, computed from 0 to 3. Now ln's can combine into a single ln of division. So y minus 7 over y plus 4 from 0 to 3. So this is the most I can simplify. Now we plug in 3 over 11. 3, so I have ln of, now observe this, guys, you have absolute values. It's not there for decoration, right? The numerator becomes negative 4, denominator is 7. So you will not be able to take that ln if you didn't have absolute values. It will be complex number. Minus ln of negative 7 over 4. Now look at this. This is another subtraction. I can combine these ln's into division. And what I get is negative 4 over 7 divided by negative 7 over 4, right? Which is 3 over 11, ln. You flip, we get 16 over 49.
Right. So 28 over 28. How do you get 16 over 49?
When you're dividing fractions, you multiply by the flip, right? So negative 4 times 4 is negative 16 over negative 49, and then negatives cancel. So 3 over 11 ln of 16 over 49. Now, if you really want to do some of the mathematics gymnastics here, you realize that 16 is 4 squared and the one on the bottom is 7 squared, so altogether is 4 over 7 everything squared, and then that square goes in front.
9.
I know. This is called mathematics gymnastics, all right?
Wait, wouldn't that be 9?
2 times 6 is 3. Sorry, 3 times 2 is 6.
Yeah, that's how you meant it.
The square, yeah, the square goes in front. So you write 16 as 4 squared, 49 is 7 squared, and then it's squared on the whole thing, and then that drops in front of ln. I wonder which result would my MATLAB take? The top or the bottom?
The top.
The top? Lame. Oh, both? Oh, okay. Experience. All right. This one doesn't have a good range like the one over there. All right. I will.
What the hell did I do to you? I will throw something at you. I will.
Do we have any more questions, or are we going home? Oh, you have questions, or let's go?
Infinity to 27. Sorry, 27 to infinity.
Wait, this just disappeared over here, Ellen. What happened? Integral of 27 to infinity?
Yes. Dx. Cube root of x. Divided by cube root of x.
Aha. Like this?
Yes.
All right. So we clearly see that it's improper integral of type 1 because there's infinity in the limit. And this is x to the negative 1/3 dx. So now we do the plus 1, right? So that's x to the 2/3 divided by 2/3 from 0 to b, which is the limit. B goes to infinity. We can kick 3/2 in front of the limit and just have b to the 2/3 minus 0 to the 2/3, which is 0. And we see this is infinity, so it's divergent. Because when you plug infinity for b, you get infinity. Does this make sense? Good. Yes. Differential equation? What happened?
Y pi of x equals
Negative y plus 5? Without using the formula, yes. So you have two ways to solve this. If this shows up on the exam, you either memorize the formula and just unleash the formula, you're done, or you can use separation of variables and go through the entire thing. So dy dx is negative y plus 5, and we do the separation of variables by dy over negative y plus 5 is equal to dx. So all of this becomes one block, right? Because you really can't get rid of this plus 5, so you have to take the whole thing down. Now, we integrate both sides. And when you integrate both sides, you are going to get, if you're using the u sub, there will be a negative that pops out. So u equals negative y plus 5 du equals negative dy, and so on. So the answer will be negative ln absolute negative y plus 5 equals to x plus c. The negative jumps in and makes the negative 1 exponent, which actually makes this to be 1 over, I want to write it 5 minus y because I can. No, actually still one more time. So the negative in front of ln changed, flip the fraction. At this point, we e both sides. And we have 1 over negative y plus 5 is equal to, remember that this is e to the x times e to the c. So you can call it, I don't know, k e to the x if you want to. All you need to do is to get this y alone. So minus y plus 5 is equal to k e to the negative x, because now we're flipping both sides. So this e to the x will be in denominator. When you bring it up, picks up a negative exponent. And then you are supposed to, you can move y and move the k. So the answer is y equals 5 minus k e to the minus x. Now the beauty of differential equations is you can quickly take the derivative, plug it back in original problem, and it must check out in order for the solution to be correct. When? Well,
if you use the formula, you get the same thing, but just with the sign switch. You get c e to the negative x plus 5.
yeah, the negative 1 gets absorbed by k, because negative 1 times k, right?
Yeah, plus 5.
I have plus 5 too. Anything else?
Yes. Now, number 44 is like, 10.1, integration from 0 to 1, square root, 1 plus 5 square root, x inside square root.
So 0 to 1?
Yes, square root, 1 plus square root with inside square root, x dx.
That one.
Yeah.
Oh, you're giving me good ideas for the test. So what should we do here?
We should make u equal to square root of x.
All right, let's try. And then what's du?
Du is 2. Yeah, I like that way.
All right. So let's see. See you next week. All right. The limits remain the same, because square root of 0 is 0 and square root of 1 is 1, so limits stay the same for U domain. Now, this becomes 1 plus u. And the dx over here is equal to 2 root x du, but root x is u, so dx is 2u du. This is called backward substitution.
How are we able to determine you have to like flip it upon the u value?
Because I had extra x, I can't plug this in because I don't have anything to cancel it with. But I see up there that that root x that I don't have to cancel anything with is actually u, so I plug it in and that's what we get. So now what? We got to this point.
Back up.
So now we have 2 integral of u root 1 plus u du. And Adam was right. We have to do another substitution. T is 1 plus u. So dt is du. And when you plug everything in, you have a square root of t, and you have a dt, but the problem is this u over here, and that u, when you solve, it's another, this is a double back substitution problem. U is t minus 1. This is a really crazy, cool problem. So this is 2. Oh, I forgot the limits. And the limits now are 0 to 2. No, 1 to 2. We have t to the 3/2 minus t to the 1/2 dt, and now it's basic Now observe that I kept changing limits along the way, so I don't have to go back to x through substitutions to figure this out, because we are technically done. This is 2 t to the 5/2 over 5/2. Oh, come on. This is the reason why I disconnected it from the, because it keeps deleting stuff that I write when it doesn't sync. Minus t to the 3/2 over 3/2 from 1 to 2. Now plug in 2. We have 2/5 2 to the 5/2 minus plug in 1 is just going to be 2/3. And we can leave it here. This is the exact answer. We can actually pull 2 out. And then you can punch this in the calculator if you want your precious decimals. I know. Correct to the 7 decimal places. Yes? Wait, did I miss something? Oh, yeah. Guys, are you paying attention? That's why you're talking, you're not paying attention, and then... Yeah. Thank you. Plug 2 into both, plug 1 into both. I plugged 2 in the first and 1 in the second, and I was out because no one's paying attention.
You can simplify those fractional powers.
Can I?
First one you can do 4 root 2. Second one you can do root 2.
Yes. So I'm going to kick 2 outside everywhere. So that's 4. 2 times 2 is 4. And then I have 2 to the 2 squared times, because this is, when you peel off 1/2, you're left with 4/2, which is 2. So I have 2 squared. It's just random stuff. And then you have 2 root 2 over 3 minus, I took 2 out, so 1/5 plus 1/3. And the simplified answer is 4 root 2 minus 1 over 5 plus 1 minus 2 root 2 over 3. And then you can get 2 decimals. Nice. You all good with this? Yes.
This one's chapter 7.3, but I'm just wondering if during a circumstance this will ever occur. Like it says, integrate from cotangent to fit power of 3x.
This is the question?
Yes. And like I know during we'll probably have this on the when we do like triangle substitution when we plug in the values.
Yeah, it can pop up. So we break off 2 and leave 3 alone. And from here, if the identity doesn't work out, you have to do integration by parts. So identity here is leave the cotangent 3x alone, and the identity for the cotangent is the cosecant cube 3x minus 1, that's squared, minus 1 dx. So now when you distribute, you get cotangent cube 3x cosecant squared 3x dx minus the integral of cotangent cubed 3x dx. So now this integral here that you see, you can solve using u sub, right? Because u equals cotangent x, du equals negative cosecant squared x dx. Oh, there's a 3 there, so there will be negative 3. So you see that the first integral can be done. The second integral now is the problem, because you have a cotangent cube. Well, peel off 1 and do the same procedure. So you have cotangent cubed, sorry, just have cotangent 3x times another one of these cosecant squared 3x minus 1 dx. And when you distribute that part, you get the integral of cotangent 3x cosecant squared 3x, and then you get minus and minus give you a plus integral dx, that's minus 1 right there. Boom, minus 1 of cotangent 3x dx. Now this integral over here, use same u sub, and this one at the end is easy because it's cosine 3x over sine 3x dx, so it's a u sub where u is equal sine 3x, and du is equal to cosine 3 cosine 3x dx. So it's a lot of u subs here, and Pythagorean identities. So once you're here, from here is easy because you are just fixing the constants, and you're having your u cubed and then u and then ln, right? For this is too busy. It takes too long.
Yeah.
Unless you're requesting it, I can.
No.
All right, just.
Like basically, it feels kind of weird how I through the longest problem there is.
Yeah.
That looks like a Nike symbol.
Yeah, that's why I put it. Just do it. Anything else?
I have some questions on chapter 10.8.
Okay. 7.8. I don't remember.
Number 20. I was worried about the integration. I'm sorry, it's from negative infinity to infinity.
Negative 2 to infinity.
Sorry, it's negative infinity to positive infinity.
Oh, negative infinity to positive. Well, I think we did this in class. Okay.
Oh yeah, you did.
Because I think they only have one.
Don't worry about it.
Yeah, there's only one from negative infinity to positive infinity, and I know I did that one.
What was this one? 0 to infinity, e to u, divided by e to 2u plus by 1.
This is your favorite tangent. We use the let's say t substitution, and then dt is e to the u du. So when you plug this in, right, 0 to infinity becomes actually now 1 to infinity. E to the u du is dt, and on the bottom you have t squared plus 1. It's inverse tangent. So limit b goes to infinity, 1 to b, of 1 over t squared plus 1 dt, which is our tangent, and the problem is solved. So a little bit of u sub there. So we have pi over 2 minus pi over 4, and the answer is pi over 4.
May I ask you, Jordan, what circumstance, I know you started from infinity to 0, how can I identify when to like switch out the variable for the integration?
Well, if you do u sub, whenever you do u sub, you have to do the limits of integration.
Like, for instance, the ln, where that one problem, chapter 7.1, where you had to switch out your ln.
Yeah. So whenever you do u sub, or in this case, because u was already used up, I use t. Anytime you do substitution is when the time when you do the switching the limits. That's when you do it.
Okay. Wait, what was this one? Number 45.
What's that?
It's from 0 to 10 dx 4 square root and that. No, sorry, it's like the 4 is this.
Oh, fourth root.
Yeah, 4 root 10 minus x.
Great. So we have fourth root 10 minus x. We see that we can use basic u sub, right? But the issue is at 10. So we have to, I'm going to use u sub. 10 minus x du is negative dx. Hit this with the negative, and then that will change the limits. So when I plug in 0, 0 will be 10 on the bottom, and when I plug in 10 on top, becomes a 0 there, and becomes du over fourth root of u. Now the negative in front of the integral will swap the limits 0 to 10, and then we have u to the negative 1/4 du. But hold on, this 0 creates the vertical asymptote, so we have to start with the limit a goes to 0 from the left, and then we have integral a to 10 of u to the negative 1/4 du. So what I did first is I did u sub first, and then, oh come on, I did u sub first, and then after that I have implemented the improper. Or you can implement improper then, but then you would have to drag a formula for a, which is not fun. So either way, we integrate, so limit a goes to 0 minus, and when I integrate this, I get u to the 3/4 over 3/4, there we go, from a to 10. 4/3 get kicked in front of the limit, and I have 10 to 3/4 minus a to 3/4. So in the limit, that's going to go to 0 because 0 to 3/4 is 0. And I'm left with 4/3 times 10 to 3/4. So it converges.
I'm going to ask you, when we're searching, how can I be identified with, if I have to make it go to the right or left with the negative, with the 0 to the negative?
As I said earlier, your interval is always a. So interval on the limit is a to b, right? And on the number line, it's a to b. A, you can only approach from the left, and b, you can only approach from the right. So that's why the limit x goes to a minus, and the limit x goes to b plus. You can't have anything else, right? Because the limits of integration are from a to b. So you are approaching a. Oh, wait, hold on. I had it backwards. You are approaching a from the right. So it's a plus. And you are approaching this one from the left. So it's b minus.
Would that mean you have to put your sign for the a then?
Yeah, I just did. Right here. It's a plus.
Where the a is 0.
Oh, did I have it backwards? Oh, yeah. It's a plus. Yep. Good catch. All right.
Like I have another example, it's on the quiz. Just wondering if I was able to put my answer. Okay, integration from, sorry, that's one we always did. So yeah, yes, so from x, limiting from 27 to infinity, x is negative 1/3. No, I'm so sorry about that. It's actually y prime is equal to x squared plus my 4.
That's the differential equation.
I'm really sorry, but it's like y prime is equal to y plus by 7, x squared plus by 4.
So y prime is equal to y.
Plus by 7, x squared plus by 4.
All right. And what are you supposed to do?
We're trying to find y equals CRKT divided by b minus a, or b minus k.
For this question?
Yes. And you're trying to find. Let me just well. Probably. Yeah, pretty much.
Oh, it's not plus, fine.
What would happen happen if it was like that anyway?
Oh, it can't be solved.
Can't be solved. Oh my god, what the hell happened? I'm like,
Well, it's possible that it's all changing.
For calculus, it's like environment basic discipline and
So that's times, not plus. Which makes this into separation of variables. So we have dy dx is equal to y 7x squared plus 4. And then we have dy over y is equal to 7x squared plus 4 dx. Integrate both sides. ln absolute y is equal to 7/3 x cubed plus 4x plus c. Hit e both sides and we're done. Y as a function of x is equal to e to the 7/3 x cubed plus 4x, and then this plus c breaks off as k in front.
But may I ask, you were during the circumstance where you said e to x was by c, I mean, how come for this one you didn't do like e to c upon like...
I did, because this over here you have plus c, so it's e to the polynomial times e to the c, which is the last part, and then I call this one k, and I put it in front.
Okay.
Yes, Kevin?
So I follow through the answer, but why is it that whenever you integrate dy over y, it becomes held in an absolute value of y? Like, wouldn't the integration of changing y be another y in front?
No, because that's equivalent to the integration of 1 over y dy. Like if you were, so similar to how on the right hand side we use 7x squared plus 4, the dx is like basically this is your like derivative integrated. That's like saying 1 over y is your derivative integrated.
And you get telling what?
But may I ask you, would there be any graphing upon chapter 10.9 when you showed us those like curves?
Most likely not.
Okay. Would that be on the final, may I ask, as well?
Could be. It's going to be definitely in Calc 3. And then you differential equations class is coming up, so yeah.
I'm sorry if I'm asking really boring questions at all.
These questions are awesome. Calc 1 asked maybe 3 questions and they bounced.
Yeah, because they're idiots.
Strong language.
Sorry,
That's-
because they're supposed to know that this is an important review of my exam. If they want to pass the class, they should honestly review it more to understand that they understand material enough to get a grade.
Young.
Stay there.
All right, what else?
Number
Guys, shh.
19 is from 2 to infinity. Cosine of parentheses pi over x. Parentheses divided by x squared. Oh, that way.
dx?
Yes.
Wait, I think we discussed this one, right? U is pi over x.
Line you can take down.
Du is negative pi over x squared. dx. So I don't have the negative pi, so I need negative pi, and I need negative 1 over pi outside to counter it. So now when I do substitution, negative 1 over pi, 2 to infinity. I have to change the limits now. So when I plug in 2, I get pi over 2. And I get, when I plug in infinity, I actually get a 0 here. And now negative pi over x, all of this is the x, so I have a cosine of u du. Pi over 2 is a bad point. I flip the integral to get positive 1 over pi, 0 to pi over 2 for cosine u du. And now we put the limit. So 1 over pi, limit, b goes to pi over 2. Actually, no. I don't need it. Right? I don't need the limit.
No, you can just do the inverse of sine.
Yeah, so the cosine is sine u from 0 to pi over 2. And then sine of pi over 2 is?
Pi over 2 is 0.
No. Sine of pi over 2 is 1.
1, yeah, sorry.
So I'm getting 1 over pi here now. All right. Find another one. Let me just see some. One more question with this. All right. What else?
I don't know if we're ever going to get this, but it's like tangent inverse of like it's from 0 to 2 on 1 divided by square root of 2y tangent inverse y squared.
Ooh, sounds interesting. Let me write it.
But
It looks too complicated for the test, but I want to write it down to see how interesting it is. Let me see.
integration from 0 to 1 divided by square root of 2.
Like this?
Yep. And y tangent inverse of y squared.
Y
Tangent inverse
tangent inverse of.
y squared dy.
Oh,
Yeah, I don't think we're going to get this on the question.
this is integration by parts, right?
Probably.
Yeah, integration by parts. Yeah, it's not a problem. So
I'll request it.
for this one, I would start with u equals y squared. Du equals 2y dy. I don't have a 2, so here's the 2. Let's see. Oh, I need limits, so when I square it, it becomes 1/2. Nice. And then this becomes tangent inverse u du. Integral of tangent inverse u du.
This one is John.
So now you can do integration by parts because you know how to differentiate tangent inverse. So u equals, oh, I can't use u now for, okay, so let me change this to t's. So that I can use u now. So u is equal to tangent inverse of t. Du equals to 1 over t squared plus 1. And then over here I have just dv equals dt and v equals t when I integrate. And as you can see, once we plug everything in, you get t times tangent inverse of t minus integral of t over t squared plus 1 dt, and this integral is u sub. U equals t squared plus 1, du equals 2t dt. And from there should be hopefully easy. It's a cool question. I need a 2 and another half, so that's going to be a quarter now. Wow, this is going to take forever to actually untangle this. Actually, no. Because that's a 0, so the limits are 1. I don't have to change it back. Half squared is a quarter. So 5 quarters. Oh, okay, not that bad. So 1/2 t times inverse tangent of t minus 1/4 ln of u. So these are computed using the old limits, 0 and 1/2. And this is computed using new limits, 1 and 5 quarters. So when I plug in half, I get 1/4 inverse tangent of 1. Yeah, no, I think the stream is still working. Yep, stream is still going. And then the 0 will give me 0, so that dies. Minus 1/4 ln of 5/4, and then ln of 1 is 0, so we don't need to do anything there. You could factor 1/4 out if that will make you happy, but we can't do much with this. So that will be the answer. Switch the color. All right.
I got this one. I think it's dy dt equals 8e to the 4t.
What happened?
I have number 18 times 7.5.
What does it say?
It says dy dt is equal to 8e negative 4t. And then below it says plus by 1. And then y of 0 is equal to 5. Same guys.
Wait, we did this one in class. I don't have the notes, but I remember this problem. I think we did exactly this one in class.
Okay. Then cancel it. Okay, what about this one? Nope. So A asks you what happens there's an interval between negative and positive a. Should you separate them out?
Yeah, so if you have integral of negative infinity to positive infinity of some function dx, you break that at any point that it's convenient to you, and then you have two integrals to work on. But the integration is the same, it's just the limits are different. So the first one will have the limit a. Well, I can't use a now. Now g goes to whatever, negative infinity, integral from g to a, plus the other limit is h goes to infinity, a to h. So you would break it up at whatever number you want, at 0 or at 1 or whatever is convenient to compute later, depending on the function you have. Like if it's a trig function, maybe you want to break it at 0, maybe you want to break it at pi over 2. If it's exponential, maybe you want to break it at log 2 or ln 2. Depending on what function you have is when you're breaking it.
Wait, what if we ever get this guy from?
Well, it's possible. I mean, why not?
It says y different. I don't know how to say it. Y prime parentheses t.
Oh, y prime of t, yeah. Like this.
Yes, equal to y parentheses 4 t cubed plus by 1.
4
T cubed cubed.
Plus 1.
Yeah, plus by 1. And then y of 0 equals 4.
All right. So this is separation of variables.
So it's like dy dt.
It's the same. It's the same problem as this one over here. Except you don't have x squared, now you have x cubed. But it's the same thing.
I got one that's like decimal now.
So dy y 4t cubed plus 1 dt, and you integrate both sides. And when you integrate both sides, you get your ln y is equal to t to the 4 plus t plus c, and then when you e both sides, you get y of t is equal to k e to the t fourth plus t. And that's it.
Okay, so what's this one? It says secant x.
Secant x?
Yes. Y prime of parentheses x equals y cubed. And y0 equals 3. Now this is fun. I know we probably will get.
So secant goes to the other side, becomes a cosine, right? Because it will be 1 over secant on the other side. So we have dy dx on the left is equal to y cubed times cosine x. Separation of variables, so dy over y cubed is equal to cosine x dx. So as you can see, not a problem. Once you separate the variables, on the left hand side, the integral of -3 is going to be -2. So this becomes y to the -2 over -2 on the left equals to integral of cosine is sine x plus c. On the left hand side, well, multiply both sides by -2, so you have 1 over y squared is equal to -2 sine x plus c. And now you have to flip the left side. You get y squared is equal to 1 over -2 sine x plus c. So this is not a, this is implicit, but it's a solution. So you would have a plus and minus in this case, and that works.
We only apply on the e if it's like ln.
Yes, to get off. Just shut off the stream.
If they ask